morning, guys. How are y'all doing? It's Friday. I have a video for us to watch.
You may remember your mother politely describing someone as big boned. Well, that would apply to this next story. Word has arrived from Spain that will rewrite everything we know about dinosaurs. Every chart that children have ever studied, all those big bones assembled in museums. This new discovery is something altogether different. Tonight, our chief science correspondent, Robert Frizzell, pieces it all together. Even in the world of dinosaurs, this was a thundering giant. Excavated in eastern Spain. The fossil bones reveal a new relative, a Allosaurus, which used to be called Brontosaurus, the biggest dinosaur on display in every museum in natural history. Mark Carell is curator of paleontology. So what it looks is pretty much the same, except a much larger animal. In fact, measuring 125 feet long and weighing 48 tons, it is fully 50% larger. What do they eat? That's a really good question, because to get to that big, they would have had to eat a lot of whatever they were eating. But from their teeth, we can tell that they're plant eaters, because the exact kinds of plants they ate, we don't really know. The newly discovered dinosaur is called Tyrannosaurus. How big was it? Its big, tall alone was the size of a football. And its humerus, bone from its shoulder to its elbow, was the size of an adult human. One of the younger visitors to the museum today. Fascination about the new giant. It's like awesome. And it looks bigger than that.
I like them because they're ancient. That's so cool.
Certainly cool enough to have made quite an impression when it walked the Earth in the Jurassic period 150 million years ago. Robert Frizzell, NBC News, New York. That's our broadcast for this Thursday night. Thank you for being with us. I'm Brian Williams. We'll look for you right back here tomorrow night. Good night.
So today we're going to start Chapter 10.1, Exponential Functions. The homework is a worksheet that Ms. Tesney has to give you. One side says skills, please work 1 through 16 all. The other says practice and work 1 through 18 all. When we talk about the word exponential, things grow exponentially. Trees grow exponentially. Bacteria grows exponentially. So to begin with, we talk about an exponential function. An exponential function is a function with a constant raised to a variable power. It is an equation of the form f of x is equal to a b raised to the x, where a is not equal to 0 and b is greater than 0 and not equal to 1. B is a base. We work in base 10. There are lots of other bases. There's base 2, that's what computers work on, base 3, and so forth. So in my equation here, I have 3x. 3 is the base. And x is the exponent. So let's look at this. So if we were to plug some numbers in a chart, what would happen? If we plugged in 0, anything to the 0 power is what? 1. So we would get 1. If we plugged in 1, we would get 3. we plugged in 2, we would get 9. What if we plugged in negative 1? Plugged in negative 1, everybody remembers that anything raised to a negative power is 1 over the number to the power. When we plug in negative 1, we get 1/3. Plug in negative 2, we get 1/9. When we graph these points, we get well, if we plot 0 and 1, we have a point right about here. We plot 1 and 3. We plot 2 and 9. We plot negative 1, we get 1/3. Plot negative 2, we get 1/9. So we have a curve that looks like this. So based on the information we have here, what is the domain of this function? Remember, the domain is made up of all the x values. So what is the domain? Domain is all real numbers. What about the range? The range is made up of all positive real numbers. As you can see by looking at our graph, the y-intercept is where the curve crosses the y-axis. So in this case, the y-intercept is 1. The asymptote is the line the curve gets closer and closer to but never intersects. The asymptote for an exponential function the function is a one-to-one correspondence. Remember that a one-to-one correspondence means that its inverse is also a function. When we talk about exponential functions, there are different types of exponential functions. There's growth. Bacteria grow exponentially. Trees grow exponentially. Population grows exponentially. So my function I have up here is f of x is equal to a times b raised to the x power. If a is greater than 0, meaning it's a positive number, and b is greater than 1, then the function represents growth. And the curve looks like this. An example might be y is equal to 2 raised to the x power. When we talk about exponential decay, we're in the form of f of x is equal to a b raised to the x power. A is still greater than 0, meaning it's a positive number, but b, the base, is a number between 0 and 1, like 1/2, 1/4. This particular function represents decay. So an example might be y is equal to decimal 5 raised to the x power, so that's y is equal to 1/2 raised to the x power. and the graph will always be in this form. You see it goes down. Look, here I have two examples. The first example you see is 2 times 7 raised to the x power. You have to raise 7 to the x power first. You don't know what that power is, so you can't multiply 2 and 7. We know that it is growth because the base, which is 7, is greater than 1, and a is a positive number. On my second example, you see where we have 2 and then 1/3 raised to the x power. 1/3 is the base. It is a number between 0 and 1. So we know that it is about decay. A must be a positive number as well. So some of the homework exercises tonight ask you to determine if the function is growth or decay and explain why. So I have an example up here. Y is equal to 2 raised to the negative x power. So what is that? What does that mean? It really means y is equal to 1/2 raised to the x power because it is a negative exponent. So this is really about decay because the base is 1/2. And if the base is a number between 0 and 1, then it is decay. My next example says y is equal to 3 times 1/2 raised to the negative x power. So what is that? That's really 3 times 2 raised to the x power. So we know that it is about growth because the base is greater than 1. 2 is greater than 1. So since the base is greater than 1, it is about growth. The next type of examples we actually worked some time ago. And I said when we get to logarithms, we'll need to know how to do this. So here we are at logarithms, and we have to know how to do this. You will need your blue sheet. If you don't have one, you'll find one on the internet. You have 3 raised to the 2n plus 1 is equal to 81. We're going to rewrite 81 in terms of 3. It is 3 to the 4th power. Once you make the bases the same, you can set your exponents equal. So we're going to say 2n plus 1 is equal to 4. Once you set your exponents equal, you can then solve the equation. If 2n is equal to 3, so n is equal to 3/2. You can check your answers always by plugging your answer back in. So if we plug 3/2 in for n, we get 3, our 2's will cancel, raised to the 4th power is equal to 81. We get 81 is equal to 81. My next example is similar. But you'll notice that you cannot write 4 in terms of 8, nor can you write 8 in terms of 4. So you've got to rewrite these using base 2. So 4 is really 2 squared, and 8 is really 2 cubed. So I've rewritten 4 in terms of 2 squared. I've rewritten 8 in terms of 2 also. It's 2 cubed. When we work these together, we get 2 raised to the 4x, and then 2, you have to distribute 3 to both of these. Once the bases are the same, this is equal to that, we can set our exponents equal, and we get 4x is equal to 3x minus 2. We solve this so we get x is equal to negative 3. Once again, you can check your answer. Go back to the original problem, we plug in negative 3. We get 4 to the negative 6 power is equal to 8 to the negative 6 power. So we get 1 over 4 to the 6th power is equal to 1 over 8 to the 6th power. So if you look on your sheet, you'll find that they are equal. Our third example says 2 raised to the x power is equal to 1 over 8. And this particular problem is a little tricky because it is a little bit more difficult to make 1 over 8 written in terms of 2. The first thing I would do is rewrite this as 2 raised to the x power is equal to 8 raised to the negative 1 power. And then after that, I would rewrite 8 in terms of 2. It is 2 cubed raised to the negative 1. So it is 2 raised to the x is equal to 2 to the negative 3. Once the bases are the same, once again, you can set the exponents equal, and you get x is equal to negative 3. Like I said, some of the homework exercises are like this. The next type of problem you have on your homework exercises says write an exponential function whose graph passes through the given points. So you've got to write down your function. So we have f of x is equal to a times b raised to the x power. From here, we're going to plug some numbers in. So the first thing we have to do is find a. We want to use the point that is 0 and y. So in this case, it's 0 and 3. So we'll plug those numbers in. Well, anything raised to 0 power is what? 1. So we have 3 is equal to a times 1. 4a is equal to 3. Once we find a, we want to take a and plug it back in our equation. So we'll take A and we'll plug it back in. So we have f of x is equal to 3 raised to 0 raised to the x power. We're then going to take our other point, the point that we are given, and we're going to plug it in for x and y. So this is x and that is y. To solve for b. So we have y is equal to 3 raised to x. And we'll plug in 6 for y. We'll plug in negative 1 for x. You have to divide both sides of the equation by 3. When we do, we get 2 is equal to b raised to negative 1 power. So, what is that? That means 2 is equal to 1 over b. We don't want that, we want b. So we multiply both equations to solve b over 1. We get 2b is equal to 1, so b is equal to 1/8. So the base of this particular function is a half. We would then go back and plug the information in. We're plugging in a. We found a to be 3, and we're plugging in b, which we found to be 1/2 raised to the x power. So now we've written an equation for the function that has y-intercept at 0 and 3, passes through the point -1 and 6. Next, I would like to go over the rules for exponents. It is an exponential function, so the rules for exponents apply. You have these on a sheet somewhere, but I would like to go over them. So, x to the m times x to the n, you're going to add your exponents. An example might be x to the 1/3 times x to the 1/2. X to the 5/6. X to the m over x to the n, you're going to subtract your exponents. So if I have 5 to the 4th power over 5 to the 2nd power, I would subtract my exponents to get 5 to the 2nd power. X to the m raised to the n, you're going to multiply your exponents. So if I have x to the 1/3 times x to the 1 raised to the 1/2, I would multiply 1/2 times 1/3 to get 1/6. X to a negative exponent, x to the negative m, is really 1 over x to the n. I'll also remind you that anything raised to the 0 power is 1, and then x to the 1/2 is the square root of x. And x to the m over n is the nth root of x to the m. If you do not remember these rules, you need to go and practice. I also need to go over addition and subtraction as well as multiplication of radicals. So the rules for radicals, we learned, you multiply two radicals together, you have to have the same index. You multiply them together, the square root of a times the square root of b is equal to the square root of a times b. So the square root of 2 times the square root of 3 is equal to the square root of 6. But don't forget that if you add or subtract radicals, you have to have the same index, that's a little bitty number, and you have to have the same number underneath the radical sign. So 3 square roots of a times plus the square root of a, you're just going to add the coefficients. So we're adding 3 and 1 to get 4. So we would have 4 square roots of a. Once again, for multiplication, if you have 3 square roots of 2, and you're multiplying by 3 square roots of 3, then you would multiply 3 times 3 to get 9. and you would multiply square root of 2 times the square root of 3 to get the square root of 6. Please go back and review these rules before you start the homework. So the next type of problems you have for tonight's homework, you're going to have to apply the rules for exponents. In order to apply the rules for exponents, the bases have to be the same. So the first example I have up here says 2 square roots of 7 times 2 square roots of 7. Or should I say 2 raised to the square root of 7 times 2 raised to the square root of 7. So the rule tells you to add your exponents. So I'm going to add the square root of 7 plus the square root of 7. So I get 2 raised to 2 square roots of 7. But you'll notice on my second example, the bases are not the same. In order for me to work this problem, I have to rewrite 81 in terms of 3. So this is actually 3 to the 4th power raised to the square root of 2 power divided by 3 raised to the square root of 2. So that's really 4 square roots of 2 over 3 raised to the square root of 2. The rule tells me to subtract my exponents, so I get 3 raised to the 3 square roots of 2. Please review your rules for radicals and your rules for exponents before you start your homework. We're going to wait and do properties for inequalities on Monday. So if you come across any of these on your worksheet, please do not work them. Just leave them be, and we'll work them on Monday. So the homework tonight, like I said, are the worksheets 1 through 16 all and 1 through 18 all. If you come across any inequalities, please do not work them. Have a great weekend.